So what do you guys notice about the graph? It's up down. So we'll say it increases and decreases in waves. You do not have to write the same thing I did, so it's fine. It's just some things to describe it. Some people in my last class says it fluctuates. There's lots of answers you can say here. Would you say that this graph generally has an upward trend or a downward trend? Yeah, upward trend. Okay. And then let's look at A, B, and C and determine if the GDP is increasing or decreasing at those points. I feel fairly confident that you guys can do this. So what would you guys say about A? Good. Thought you did. And then B is also decreasing. That's just looking if there's a positive or negative slope. So you guys learned a lot about that in Algebra 2, and we've already talked about that this year too. Okay, so this is when things start getting new, ish. So the maximum minimum values are the peaks and troughs. So I'm just going to label those with a P or a T. And then what is the rate of change at these peaks and troughs? We talked about this yesterday. 0. Good. So don't forget that anytime I put ROC, I'm talking about rate of change, and I'm just kind of being lazy because I don't want to write it out. All right, and then is the GDP increasing and decreasing at a constant rate? For that to happen, what type of function does it need to be? Linear. A linear function is the only function that increases and decreases at a constant rate. So I'm just going to say the graph is not linear. Okay, at the point D, the GDP is definitely increasing because there's a positive slope. But is the growth in the GDP speeding up or slowing down? Or in the place of growth, you can think of the rate of change. So what do you guys think at D? Is slowing down because it's starting to level off, it's getting flatter. So there's lots of ways you can word that. It's definitely slowing down. That's the only way you can word that. You could circle it if you want to. The reason we know is because the graph is getting flatter. That's not the only way to word that. You can say leveling off. Lots of ways you can say that. Oh, okay. My iPad, part of that is missing, but it's up there, so that's good. All right, so for number 6, when is GDP changing the fastest? Not everything. I'm not sure why that happens, but it's kind of annoying. There we go. All right, so look at the graph. It is not at an A, B, C, D, E, or F. But there is something there where it's growing the fastest, where the slopes are the steepest. What's there? It's the dashed line. So all these points at the dashed lines is where the GDP is changing the fastest. And that's because the slopes are the steepest. Now you might have said like between B and C, between F and D. I mean, there's lots of ways you could have said that, but that line is there for a reason. All right, so at point E, is the slope of the curve positive or negative? Negative. I'm just going to circle it. So what does it mean about the GDP or the economy? The economy is decreasing. the value of products is decreasing. There's lots of ways you can word that. That's fine. Okay, now at point E, are the slopes increasing or decreasing? So like I say, that E is definitely a negative slope. So as you're going away from E, are those slopes getting more negative or less negative? That's a weird question, but what do you think? More negative or less negative? They're getting less negative. So like E might be like -2. And then if we went to right here, that's probably -1. So less negative means a bigger number. So in this case, and I know it's kind of hard to think about it right now, the slopes are actually increasing there. Right. And then what do you think that means about the economy? It's starting to turn around. Still decreasing, but not as quickly as it was before. All right, so let's talk about point F. F is a good point for the economy. Okay, so at point F, is the GDP increasing or decreasing? The GDP is increasing. What about the rate at which the GDP is increasing? Do you think that's increasing? Are the slopes increasing there or decreasing? They're increasing. So that means that the country is coming out of a recession. Now I'm going to show you a way that you can just look at a graph and you're going to know if the slopes are increasing or decreasing. And you're not, it's going to take a minute. You're not going to like know it fully the first time you see it. But I can look at any graph without like really thinking, just because I've taught it in calculus so many times, and just know about the slopes increasing or decreasing. So let's talk about these points here. Each one of these points are called points of inflection. All right, there's a lot going on in that graph. And they're important points in business. So that's when you start seeing like things changing the fastest, which is usually what you want to see in a business model. If you have two different color highlighters, you might grab them. I have tons of highlighters. If you want to grab one of mine, it's not necessary. If you don't want to highlight, it's okay. Sometimes it helps to see it visually in a different color. But what I'm going to do is highlight everything above that dashed line. I'm going to highlight that in green. And then you probably can just write with your highlighter. My highlighter is too fat for me to write with. So, but those are areas where the graph is considered to be concave down. And on the other side, we're going to write some more things, but concave down looks like a frown. So that it rhymes and it looks like a frown. That's how I can remember the difference between concave down and concave up. And anytime a graph is concave down, the slopes are decreasing, or the rate of change is decreasing. Concave down means it's decreasing. And we're going to write it on the next page. You don't have to write it on here. It's okay. All right. And then in pink, I'm going to highlight everything below that dashed line. And you probably can figure out that that's concave up. And concave up looks like a cup. And it rhymes. And you don't have to have the whole cup. So this kind of gets confusing. You can't just have half of a cup and it's concave up. And you can have half of a crown and it's concave down. So it's just to look at the curvature of the graph. And everywhere a graph is concave up, the slopes are increasing or the rates of change are increasing. You guys are actually learning this before calculus learns it. So Jacob's getting a head start because this one, I don't know if listening to music. No, you're listening. All right. Okay, let me give you guys your notes. And it's going to take a minute, but we'll talk about this multiple times per year about concavity and what it means about the graph. You'll get it. Okay, so just like we talked about before, yesterday, I guess it was, the value of the slope gives the rate of change. Those words are pretty much interchangeable. When you're talking about slope, you're talking about rate of change. When you're talking about rate of change, you're talking about slope. All right, if the rate of change is increasing, that means the slopes are also increasing. And that means the graph is concave up. And concave up looks like a cup. Right? When the rates of change or the rate of change is decreasing, the slopes are also decreasing. And the graph is concave down. And that looks like a frown. Right, and a point of inflection is where the concavity changes. And it also happens to be where the graph has the steepest slope. So we're changing from concave up to concave down or concave down to concave up. And there is the steepest slope at those points. All right, so this first example is not a contextual situation. It's just a graph that we're calling f of x. It doesn't mean anything. So we're just going to just talk about the parts of it. We're going to start with the point where x is -1. So is the function, just regular old function, increasing or decreasing at -1? This is old math. Increasing, because we have a positive slope. So f has a positive slope at x equals -1. All right, so 2 asks, is the rate of change of f increasing or decreasing? This is the new stuff. So at -1, what you need to know at -1 is this graph concave up or concave down at -1? What do you think? Concave down. If we're concave down, is the rate of change increasing or decreasing? Decreasing. Oops. And we know that because f is concave down at x equals -1. Now, I know it kind of feels like we're giving a lot of details, but we need to. You can't just say the reason is the f is concave down, because sometimes the f is concave up. So you have to be very specific. You're never going to say it is concave down. You need to name the function, because there could be more than one function going on in this problem. All right. Let's do number 5 and then come back and do 3 and 4, because we kind of need to know number 5 first. So let's estimate the point of inflection. So what x value does it look like we're changing from concave down to concave up? Ish. We don't know for sure. What would you say is in between? What two numbers is it in between?
0.
0 and 1. I would say it's about right here. You might say it's closer to 0 or closer to 1. I'm going to say it's right there. All we can do is estimate it. It's okay. So I'm going to say that it's about 0.75. And then what do we say about how a graph changes at the point of inflection? Changes the fastest. It has the steepest slope. Let's say it changes. I didn't write that here. I'll go back up and write that it changes fastest. Okay, so I'm going to be a little more specific because it doesn't have the steepest slope of the whole graph. Because if we look, you can tell like right here, that's steeper than that right there, and so is this. So I'm going to be a little more specific on this, on number 5. So we're going to say F has the fastest rate of change. Let's just do ROC. At x equals 0.75 relative to the values around it. Okay, let's go back and do number 3. So if we're saying that point of inflection is when x is 0.75, what would the interval be where the whole graph is concave down? Right, so it starts being concave down when it becomes a function at -infinity. And it's going to be concave down until you get to that point of inflection, which is 0.75. All right, you guys try to do the concave up interval for me, please. So 0.75 we're changing, and then it changes to concave up all the way to the end of the graph. Any questions on that? All right, we're going to skip number 6 because in the grand scheme of things, it's not as important as 7 and 8, and I don't want to have to rush through 7 and 8. All right, so on number 7, the number of active users on a social media platform with respect to days since the platform was released can be modeled by this function u. The table gives the value of u for selected values of t. All right, so A asks, is the number of active users increasing or decreasing? So this is the number of active users. Would you say that's increasing or decreasing? Increasing. I'm just going to circle it. All right, B, is the graph of u concave up or concave down? What do you need to be able to answer that question? Rate of change. Does this graph give you the rate of change? Or this table? No. Can we? Do we know how to find the rate of change? Yes. So I purposely left some space. We're going to add a column here where it's the rate of change of U of t. Now, the columns are not going to be the same. So we're finding the rate of change between 1 and 2 and 3 and 4 and 4 and 5. So I know that looks kind of weird. You're not used to seeing a table like that. All right, so remember a rate of change. This is going to be U of B minus U of A over B minus A. And we're doing consecutive days. So what's that B minus A always going to be? It's just going to be 1 because the days are consecutive days. So all I really have to do to figure this out is take 724 and subtract 604. So take a U value and subtract the previous value. So that's going to be 120. And then same thing, that's going to be 133, 147, and 161. So I'm doing the slope formula, but I know my denominator is going to be 1 every time, so I'm just kind of doing it fast. Okay, so those rates of change, would you guys say they're increasing or decreasing as we go across? They're increasing. So what would you say? Is this concave down or concave up? Concave up. If you don't have that memorized yet, it's okay. It's on the other side. It might take a minute. But when the slopes or rates of change are increasing, the graph is concave up. So I found all those slopes. They're definitely increasing. Now, we have to be careful. If we didn't have consecutive days, we couldn't answer this question. So, like if it went from day 1 to day 4 to day 8 to day 25, we wouldn't know what was happening in between those days, and we couldn't answer the question. But we do have consecutive days, so it's okay. So we're going to kind of write that. We're going to say we know because the rate of change for consecutive days is increasing. Whoops. Sorry. So sometimes you might not have all the information you need, but you can find the rate of change to answer questions about concavity. All right, and then this last question is about temperature in a town. And so the function is called f of h. F is the temperature in degrees Fahrenheit over a 24-hour period where h equals 0 represents 12 a.m. All right, 4 temperatures are recorded throughout the day in 6-hour intervals. And the first question you guys probably could have done in Algebra 1, honestly. So it just says to estimate the temperature of the town for the 4 times. So it's just reading the graph, basically. So at 3 a.m., I would say that's about 37 degrees Fahrenheit. 9 a.m. is 50. Now, each one of these times are special times. So they're peaks or troughs, or they're points of inflection. And so B wants us to describe how the temperature of the town is changing at these 4 times. So let's start with the peaks and troughs. Now I'm just gonna group them together because the same thing's happening. So our peak and trough are at 3 a.m. and 3 p.m. How's the temperature changing at those times? If they're peaks. Sorry? Not at the peaks and troughs, what's the rate of change? It's 0. So because the rate of change is 0, they're not changing. So the temperature, we'll say temp, is not changing. If you want to say the rate of change is 0, you can. It didn't ask to explain why. I think when I did your answer key, I wrote why just so it would trigger something in your head if you were confused about that. All right, and then the points of inflection are at 9 a.m. and 9 p.m. Oops. All right, how's the temperature changing at those times? Points of inflection changes the acids. So the temp changing the fastest. One more problem is going to kind of bring it all together. So we're going to describe how the temperature of the town is changing over the intervals between these 4 times. All right, so we'll start with between, I don't know why I can't write the right number. Okay, between 3 a.m. and 9 a.m. Okay, so we're talking about this section right here. Would you say the temperature is increasing or decreasing during that time? Increasing, because there's a positive slope. All right, would you say the rate at which it is increasing, the rate at which it's changing, would you say that's increasing or decreasing? It has to do with concavity. Are the slopes increasing or decreasing here? Increasing because we have concave up. So the temperature is increasing at an increasing rate of change. And I would say temperature really does do this. Like in the morning, it's obviously getting hotter, but it's getting hotter at a faster rate, and then it kind of slows down. All right, so we're talking about between 9 a.m. and 3 p.m. So we still have a positive slope, so the temperature is still increasing. All right. What, do you guys think the rates of change are increasing or decreasing in that interval? Decreasing. So at a decreasing rate of change. Still getting hotter, it's just not getting hotter as fast as it was earlier. All right, and then one last time interval. You guys try this last one on your own. So we're talking about what's happening between 3 p.m. and 9 p.m. Oh, shoot. Sorry. Okay. Definitely decreasing here. You can leave your calculators on your desk if you don't have time for anyway. Would you have turned it into the purple box? Oh, you turned it